Hi, we're now back again. But as I said last time, we'll be talking mostly about binary tree traversal this time. Well, right now it's going to be nerve wracking because it's my first time explaining about binaries. So, my apologies if my explanation is crude. But, anyways, we'll first talk about what tree traversal does. Well, it's simply about accessing each node inside of a binary tree, where unlike linked data structures like array, linked list, or anything related, you can traverse through the data in a straight line, or call it an index to get the element instantly. But in binary tree, you have to consider the different directions that the tree has, and giving you the freedom on how to traverse through the binary tree in multiple ways. So in binary tree traversal, there's supposed to be two different categories. And the first one on the category is BFS, or Bread First Traversal, not best friends. And the topic that I will be explaining in this video is DFS. In other words, Depth First Traversal. I have no idea on which one to explain, so I'll just go for the longest one for more points. In DFS, there's three different categories of traversing. First is in order traversal. Second, pre order traversal. And third, post order traversal. But for this video, I will only explain only one traversal. And that is the first one, the in order traversal. Anyways, let's get straight to the topic. So, the direction of how the in order traversal traverse is from left to right. Well, to be more specifically, to the left side of the tree, then to the root, and then to the right side of the tree. But anyways, I will still show you the visualization on how the in order traversal traverse. So now that we're in our presentation, I will now show you the visualization on how the in order traversal tree works. So here we are, we have a tree on our screen. And as I said before, we're going to start the very left of our tree. So in our case, it's going to be the number 4. As the order goes, it usually goes from left to the root and then to the right. So after the number 4, we'll now go to the number 2. After going to the number 2, of course, we have to include number 5. Now this part, we have to traverse from number 5 to the number 2 and then to number 1. After that, we're going to now include the right side of the tree. But as I said before, what we should need to do is going from left to right, right? So that's why we have to go through number 3 and then to number 6. After going to number 6, we can now go back to number 3 and then we have to include number 7. And that's how the visualization of in order traversal usually goes. Now that we have learned the visualization of the in order traversal, now let's try to execute the code in C. Hi, so now that I'm on my PC, we can start making we can start making the code on how to make a in order traversal in C. So of course, let's start with the library. Oh, that is a comma and dot. Be careful. Next one, we can do it stdlib, studio library in short. Now we have to make the main itself. And then, okay. So first off, we have to make the tree. Then we need to make struct node. Let's make it node. We need that? I don't think so. Next is we need to make int data. Then we need to make another. We need to make struct node. We're calling it struct. And then we're calling it to the left. Do the same thing, but this time it's going to be on the right. Next one, we need to make what's that again? We need to create the nodes, which is the circles, or the circles that contain the numbers. So we make struct node new node. Let's name it new node. And then we're taking the integer x, or we're taking the root number, and then we have to make the memory allocation for the size of the node itself. So we call node, and call it node, and then call out the struct node over here. Misspelled it. Then add a pointer, a malloc for memory allocation. Then we're gonna take the size of the struct node. Now that we have created the size of the struct, size of the tree, we're gonna create we're gonna try and make the circles themselves. Node, say node pointer data, point to the data, and now we're calling root. And then we do the same thing, but this time for left and right. But make them empty the inside. Nope, I have to call it left. That is not left. Null. Do the same thing, but this time on the right. Yeah. Now we have to return to node. To node. And then we have to create the node themselves. So let's try 1 to 6. Let's try 1 to 6 to make something more different. Calling out the node in order to create ourselves a root. And let's name it new node. We're calling out this one, this guy right here, so that we can create the data itself. New node 1. So root is now, oh wait, no, that's not 1, that's an R. New node, so number 1 is our root itself. So now we're gonna create the left and right of the root. So we're gonna call root left, and now create a new node, which is a circle, for number 2. Root, we're gonna do the same, but this time on the right. And then yeah, new node 3. And then we have to call out again. Then we're gonna call no, we have to do it again. Make the left as a parent now this time. So we call out left, then we call out left again. Then we make a new node out of it, and that is number 4. Do the same thing, but this time on the right. This time on the right, and it's number 5. Now we can technically do the same thing on the other side, but then we can do, oh, we have to call the right side this time, which is the number 3. Right, right. We have to call left and right. Now this one is 6. This one is 7. So technically it should look something like this. Oh, too much. Yes. It should look like something similar to like this. So, yes. So now we're going to call out, it's going to start from the very left. Okay. So next part that we're going to do is to make the in order traversal itself now. Void in order. Let's name it in order. Now we're calling out the struct right here. Struct node. We have to make curly braces. Inside of it, we're gonna make if node is equals to none, null. That is minus null. Then we're gonna return. We're gonna give it a return function. But if it passed, if it's not anything, well, we're gonna start doing a recursion, which is calling the function itself. Node is pointing to the left. Now we're gonna try print it the traversed the current node, visiting the current node. Yeah. So we're gonna call %d, make space so that it looks nice, and then the data of the node, pointing node to data. Next one, we're gonna do another recursion, but this time we're gonna point it to the right. And I think that's it. Yes, that's it. That's why it's really nice, because it's really short also. Anyways, my apologies. Anyways, so how the traverse will go is from 4, 2, 5, and then 1, and then to the 6, and then to 3, and then to 7. So it should look like 4, 2, 5, 1, 6, 3, 7. Uh-oh, there's no semicolon. Oh my god, I forgot. There you go. What? Why is it empty? Oh, I forgot to call it. Oh my god. That's why you don't. That's why you should not be a goofball in situations like these, you know? I literally forgot to call out the in order function itself. So now we're calling in order, and then we assign the root itself, which is our root right over here. And then we print a new line. Oop, that is M. Now in theory, it should work. Oh my god, I'm such a goofball. So there you have it. That is in order traversal for binary search traversal. I hope you enjoyed the video. I hope you learned anything from this video. See you next time. Peace out.